Our vast universe is home to phenomena such as star-devouring black holes, rapidly rotating pulsars, radiant nebulae birthing stars, and countless galaxies. Yet it may not be endless. There could be a distinct edge, a cosmic boundary. Let's embark on a journey to that possible frontier. Visualize the universe as a massive layered structure. At its core is Earth, enveloped by our solar system, which is in turn housed inside a galaxy within this grand universe. As we journey beyond our solar system, passing by the planets from Mars to Neptune, we encounter the heliosphere. Here, the solar wind's velocity plunges dramatically, giving way to the near-stagnant wind at the heliopause. Beyond, the ship faces the force of the interstellar wind. Two remarkable emissaries from Earth, Voyager 1 and Voyager 2, now reside in this region. They revealed the heliosphere's uneven shape. Venturing further, an asteroid belt known as the Oort cloud becomes visible, believed by some scientists to source Earth-bound comets. Beyond lies the expansive Milky Way, spanning around 106,000 light-years. Guiding our journey is a cosmic map, identifying our location in the Laniakea supercluster. However, there's more. At a greater scale, the Hydra Centaurus supercluster emerges. At the universe's maximum observable scale, a surprising revelation awaits, evidence suggesting a universe boundary. This edge, located an astounding 10 billion light-years away, is a testament to time and evolution. During such a lengthy voyage, our sun might wither or explode, and the Milky Way might merge with the Andromeda Galaxy. Our endpoint is the Eridanus supervoid, a vast empty stretch spanning 1 billion light-years. This void might result from an unfathomable collision, our universe meeting another. This leads to a tantalizing notion of multiple universes, where every choice leads to alternate outcomes in parallel realities. Imagine our universe as a bubble. Eons ago, another bubble universe brushed against ours. Their gravitational interplay caused cosmic distortions. As they separated, a piece of our universe might have been taken, leading to the creation of the Eridanus supervoid. Eridanus supervoid covers a region of space about 1 billion light-years in size. This makes it one of the largest known voids in the universe. This superwave is associated with the so-called cold spot in the cosmic microwave background radiation. The temperature in this spot is lower than the average temperature of the background radiation. The exact origin and nature of Eridanus supervoid is still a subject of research. This object provides scientists with a unique opportunity to study the structure and evolution of the universe on large scales. Yet, perceiving the universe's entirety remains a challenge. Like an ant on a basketball, we see a consistent horizon due to our 3D viewpoint. But adding dimensions could change our perceptions. Could black holes, with their powerful gravitational influence, offer a passage to these other realms? The vast expanse of our universe is filled with intriguing structures, mysteries, and phenomena that continually challenge our understanding of the cosmos. The Eridanus supervoid, with its immense size and enigmatic nature, stands as a testament to the universe's capacity to astonish and confound us. And for those intrigued by the enigmatic nature of black holes, we invite you to explore more in our other videos. Dive deep into the mysteries of these cosmic giants and join us on a journey of understanding and wonder.
The Earth might be on the verge of a huge change. Scientists have discovered that every 200 million years, comets start raining down on our planet. This comet shower changes how the Earth looks, reshapes the continents, and increases geological activity everywhere. We are in the 20th cycle, which means new transformations are coming soon. Why does Earth have active plate tectonics and continents, unlike any other planet? To learn the truth, geologists decided to check out zircon crystals. We often find these tiny crystals in rock. They're very tough and can survive crazy geological processes that could destroy most other minerals. But they're cool because we can use them to learn how old their rocks are. These crystals have some uranium in them, and it decays into lead over time. By measuring how much uranium decayed in a crystal and how much is left, you can figure out the age of a mineral. So, we can use this trick to learn a lot about the Earth's crust and history. Recently, geologists checked out zircon crystals from two of the Earth's oldest continents and regions, the North American Craton in Greenland and the Pilbara Craton in Western Australia. It turned out that rocks from these continents could tell us what happened to our planet during the Archean Eon, from 2.8 to 3.8 billion years ago. It was a crazy era for our planet, back when magma, rich in elements we've never seen before, pierced the surface and broke out for the first time. This event changed what the land looked like forever. And when scientists studied them, they noticed something else. It looks like there's a cycle where every 200 million years, the Earth starts forming new continental crust for some reason. When they explored this further, they suddenly realized that this might be because of our galaxy. Our solar system is located in the Milky Way galaxy, right here in the Orion Arm. An arm is a place that has tons of stars, gas, and dust. There are many of them in the Milky Way, bigger and smaller ones, and they extend and wind outward, making galaxies look like spirals. We're located in a minor arm, about 27,000 light-years away from the heart of the Milky Way, a horrifying black hole called Sagittarius A star. But our solar system doesn't just stay in one place. It moves at a breakneck speed of 150 miles per second. That's like crossing the Earth 22 times in an hour. Just like planets move around the sun, the solar system rotates around the center of our galaxy. This orbital period is called one galactic year. Objects that are closer to Sagittarius A star move faster. You know, your typical inner lane advantage. But large arms, the ones that are further away from us, are much slower. They move at a speed of about 130 miles per second. That's just some 19 runs around the equator in an hour. Because of this difference, the solar system moves kinda in and out of the galaxy's spiral arms. This is like when fans make a wave in a stadium. This leaves a mark on both the solar system and our planet. There is a vast, distant region around our solar system called the Oort cloud. It's about 4.6 trillion miles away from the Sun, like traveling to the Sun and back 50,000 times. Now, the Oort cloud is filled with comets. You might not know this, but they're way more dangerous to us than regular asteroids. Asteroids come in different sizes and are usually just rocks with some metals. They don't have a glowing gas around them. They just vibe around the Sun in their main asteroid belt, somewhere between Mars and Jupiter. And if the almighty Jupiter with its crazy gravity doesn't stop them, sometimes they come down on us, causing some havoc here and there. But a comet is a small object made mostly of ice and rock. When it gets close to the Sun, it heats up and releases dust and gas. This forms a glowing cloud around it called a coma. This is what we see as a tail as the comet moves, and their consequences are much more extreme. When we complete one galactic year, the icy objects from the Oort cloud are pushed towards all our planets. And when we enter the big spiral arms of our galaxy, the rainstorm begins. Comets are much faster than asteroids. When they hit Earth, they leave huge impacts and leave giant craters. The energy from these impacts can melt huge parts of Earth's crust and mantle. The molten rock then rises to the surface, floating there. As it cools, it solidifies and forms a new crust. Over time, these small pieces of crust can merge and grow larger as more solidified magma attaches to them. Eventually, all this forms big continents. So, once in a galactic year, when comets start hitting Earth more often, they really change the Earth's structure and help create new land masses. Another proof of this is spheroidal beds. This is what we call tiny round particles created by material thrown out during impacts. When we look at them, they also match the cycle timing. Spheral beds on our planets formed exactly when the Earth was crossing the Milky Way's spiral arms, and most of them formed when it was just over 1 billion years old. There are many cycles that influence our planet. For example, the Milankovitch cycles, the ones that tell us how the Earth's orbit and tilt change over time. This affects the planet's climate, but this new 200 million year cycle is a whole new level. We used to believe that continents only formed because of things that happened deep within our planet. And, well, maybe asteroids influence it a little. But now it seems like the continents were born and shaped thanks to the Milky Way itself. Scientists now want to study these ancient deposits to see if it's actually true. If it is, it could mean that we're getting closer to some huge geological activity. The continents might start reshaping again, or even coming together to form a new supercontinent. The continents on our planet look like puzzle pieces that fit very well, like South America and Africa. And that's not a coincidence. Many years ago, they formed one supercontinent called Pangaea. Pangaea used to be a landmass full of unique creatures, like the giraffe-necked Tanystropheus, the toothless Lystrosaurus, and the reptile bird Drepanosaurus. But the ground beneath us is always moving, floating on magma like vegetables flowing on a super hot soup. And eventually, Pangaea broke apart. However, it wasn't the only supercontinent in our history. This coming together and then breaking apart happens pretty regularly, like with some toxic people. Usually it happens every 200 to 600 million years. So yes, all our current continents will come together again one day. We call it Pangaea Proxima, Pangaea Ultima, or simply Amasya. It could form during the next galactic year. There are many theories about how it might happen. Africa might merge with Europe, and Australia might move north towards Asia. Life on Pangaea 2.0 would be challenging. People would likely have dark skin, hair, and eyes. We would all hang out near the equator and along the coasts because the weather would be nicer and calmer there. The center would be horrifying, hot and dry, filled with deserts. There would be a common language and shared traditions. In general, such an event would really bring us closer together. No pun intended. However, it would also mean that if someone starts fighting, we're all screwed. Also, all the potential health issues might influence everyone on the continent. And let's pray that there won't be any large asteroids this time, or we're definitely doomed. This, of course, the movement of the Earth's crust will lead to a lot of cataclysms. But maybe humans won't even live on Earth by that time. Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Sears 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution early release SINCE survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun. and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter, about 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment.
Okay, so let's assume this teeny-weeny grain of sand, just about 0.1 inches in diameter, is our home planet Earth. Trust me, we're not even that big on a cosmic scale, so I'm flattering us a lot. You'll see. Anyway, the moon will be just about here, a little over 2 inches away, and we'll have to find a grain of sand that's 3 times smaller than the first one. It's hard to say if this is the one, so let's again assume it is. Now, what's the closest neighbor to Earth apart from the moon? That's right, Venus. It's called our sister planet because it's roughly the same size and mass. So this here grain of sand is gonna be it. As for the distance, we'll have to take a little walk now. And there we go, over 20 feet away from the grain that is the Earth. And that's at its closest, mind you. Next comes Mercury, and it's more than twice as small as the Earth. So let's take a grain of salt this time for variety. How far do you think it is from its neighbor, Venus? Not even close. It's here, almost 26 feet away. If you've ever seen a London double-decker bus, it's just short of that vehicle's length. Okay, Mercury is the closest planet to the Sun, so naturally, here goes. The big and mighty star, measuring as huge as this rock. It's roughly 8 inches in diameter, so it fits. Now, where should I place it? Well, you'd better take another double-decker, and then some, because the Sun's distance from Mercury is 30 feet, even further than Venus. And a walk from here to Earth is quite a trip already. All in all, the distance is just short of that between 2 baseball bases. Cool, huh? But we've only just begun. Moving away from the Sun, next comes Mars, which is twice as small as the Earth. Let it be a red pepper grain this time. The distance to it, though, is even greater than from Mercury to the Sun, over 33 feet. So we'll place it here. And now, prepare for the real thing. we're crossing the asteroid belt to reach Jupiter. To do that, we'll need to travel about 275 feet. That's almost the height of the Statue of Liberty. And the planet itself is about the size of this grape, just shy of 1 inch. Now, let's take a smaller grape and fly another 330 feet. That's how far Saturn is from Jupiter. Can you still see our rock? Sun, from here? I don't think I can. Now, if you take the Golden Gate Bridge in California and decide to rise from its lowest to highest point, that would be the distance from Saturn to Uranus, the 7th planet in the solar system. Notice how distances grow larger every time? That's far from over though. Meet Neptune, Uranus's brother planet. Although they're neighbors, it'll take us another 820 feet to get to it. Put 5 Olympic-sized pools in a line and you'll get the scale. The former Planet 9, Pluto, is our next destination. If we go straight from the Sun, it'll be yet another 4 Olympic pools away, and the size of it is only a speck of ground pepper. Pluto is 6 times smaller than the Earth. And now comes the barely imaginable. Let's first go back to our Sun and start the journey from there. Remember how far that is? Right, more than a half a mile away now. To get to the inner boundary of the solar system from this point, we'll have to travel around the whole planet 4 times. Yep, we're still on the scale where the Sun is just an 8-inch rock. And when it's done, we'll find ourselves in a humongous belt of floating chunks of ice, the Oort cloud. The width of this belt is way beyond our planet's limits, but we'll try. Let's take 3 rocks of the same size as our Sun here and lay them in a line. And now, imagine each of these rocks is the size of the real Sun. That's the width of the Oort cloud for you, which goes in a circle around the whole solar system. If we put it to our initial scale, the Sun won't be even visible, no bigger than an atom. So let's scrap it now and start over, shall we? Okay, now this ring of stones contains within it the unfathomable volume of space. Its radius is roughly 1 light year, or 0.4 inches now, and that would be our ground zero for all the following discoveries. The closest star system from here is Alpha Centauri, and it will be about 1.5 inches away. It consists of 3 stars and at least 1 planet that could be inhabitable. The system is too small to see on this scale, but we'll pretend this grain of sand is adequate and proceed further. Next, we go to the edge of the Milky Way galaxy, our home. The galaxy itself is about 100,000 light years across, but we're not far from its very center, so the journey will only take us 50,000 light years. On the super shrunken scale we've created here, it will be 1,650 feet. If you lay down the CN Tower in Toronto, it'll only be a few dozen feet longer. From here, the nearest galaxy to us is the Andromeda. In some distant future, it'll collide with the Milky Way. But right now, to get there, we'll need to travel nearly 15 miles. That's 2.5 million light years in normal count. If you're interested, it's also 2.5 depths of the deepest point in the Mariana Trench, known as the Challenger Deep. Next up is an object we could finally place on a larger scale. NGC 604, a star nebula located in the Triangulum galaxy. If it were in a single line, we'd only need to travel 1.2 miles from where we are now, so let's do it. And the nebula itself is about 1,500 light years in diameter, which is equivalent to 50 feet. That's like a 5-story building. But let's get back about half a mile and look at something else. This object is almost exactly the size of a Boeing 747, and surprisingly, it's a galaxy. A dwarf galaxy, to be precise. Messier 32 is 6,500 light years across and is a satellite to the Andromeda galaxy. They move together, Messier being tugged along by the gravity of its big sister. And now, I'm going to take you for a ride of your life. Get ready, we're going into distances and sizes that would seem impossible if they weren't true. Let's first get back to the circle of rocks that is our solar system. Moving up and away from our star system, we can see the Milky Way galaxy, spanning 0.6 miles wide. Shooting upwards still, we see the great emptiness around the galaxy that we've already crossed today. 15 miles of nothingness. Then, we see the galaxies and dwarf galaxies surrounding ours. First, the Andromeda, then others, until we're high enough to see the whole local group. It's a galactic cluster in which the Milky Way is no more than 1%. The diameter is 62 miles. But higher still we rise, and now we're looking at a bright and shiny Laniakea supercluster, which is home to the local group. From here, our galaxy isn't even visible. The diameter of the supercluster is about 3,200 miles. It's more than the distance from Los Angeles to New York. And even that's not all. Higher and higher until we see the boss Great Wall. It's a supercluster located unimaginably far from us. And on our current scale, its diameter is about 6,200 miles. That's longer than the Great Wall of China, with all of its branches. No wonder it's the boss. And finally, we're up in outer space now. Even though the model of our whole galaxy stayed so far below, you can't see it without a telescope. And we're now looking at the largest object in the observable universe, the Hercules Corona Borealis Great Wall. On the current scale, it's as far as 62,100 miles away from Earth, or a quarter of the distance to the Moon. And its diameter is the same, so it takes up another quarter of the way. There are trillions upon trillions of galaxies, nebulas, and stars, and nearly infinite possibilities out there. And yet, the universe is always expanding, so it's also only the beginning. A recent study suggests the universe is similar to your brain, only at a much, much larger scale. The brain's neural network contains about 86 billion neurons. The observable universe has at least 100 billion galaxies. Both galaxies and neurons have a similar structure. It's a complex web of nodes linking up long thread-like fibers. But in each of these systems, the fibers make up a mere 30% of the total mass, and the remaining 70% are either water in the brain or dark energy in the universe. The ways that galaxies and webs of neurons connect with one another are surprisingly similar. In both cases, the process follows the same physical principles. At the same time, some researchers claim the resemblance between the brain and the universe is only superficial. Your mind perceives tiny details and joins them, and then it comes up with a conclusion that has nothing in common with reality, like the brain is a mini-universe. In billions of years, the universe is likely to expand so much that we won't be able to see any stars in the sky. To turn Earth into a black hole, you'd have to squeeze it until it was the size of a marble. And if you wanted the sun to become a black hole, you'd have to compress it until it's no more than 4 miles across. A starburst galaxy is a galaxy that's forming tons of new stars at breakneck speed. It usually happens after 2 galaxies merge into one. While Earth has only one natural satellite, Jupiter is surrounded by at least 79 moons. In the universe, there are not only dwarf planets, but also dwarf galaxies. They have from 1,000 to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. A supermassive black hole 250 million light-years away from Earth hums the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. Planet Kelt 9b is 670 light-years away from Earth. It's an ultra-hot Jupiter. Those are giant, scorching hot planets with a mass similar to that of Jupiter. On Kelt 9b, the heat is so great on the day side of the planet, it tears molecules apart. Any liquid floating in outer space forms itself into a sphere. It also happens in low Earth orbit. Our home Milky Way galaxy is more than 105,000 light-years across. all the planets of the solar system would fit between Earth and the Moon with some space to spare. Black holes spaghettify things. It happens when something gets past the point of no return. Then the black hole's gravitational pull starts to stretch this object in one direction and squeeze in another. The first celestial body that astronomers identified as a spiral was the Whirlpool Galaxy. Its long arms are made of gas and stars, and everything is sprinkled with fine space dust. When you're on Earth, you can only see 5% of the universe. A star coming too close to a black hole can be torn apart by its gravitational force. WASP 12b is a giant planet 1,400 light-years away from Earth. It's made up mostly of gas. Unfortunately, the planet is doomed. It orbits too close to its parent star. In about 10 million years, WASP 12b will be swallowed by its greedy sun. Our Milky Way galaxy and the Andromeda Galaxy, its closest neighbor, are going to meet in a bit less than 4 billion years. When they collide, they'll form one huge elliptical galaxy. One of Saturn's smaller moons, Enceladus, reflects almost 90% of the sun's light. It makes the moon one of the brightest objects in the solar system. But since it reflects sunlight instead of absorbing it, the temperatures on Enceladus's icy surface drop to -330 degrees Fahrenheit. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest. If you were standing on top of Olympus Mons, its slopes would be hidden by the planet's curvature. In our solar system, Mercury and Venus are the only 2 planets without moons. Scientists who are planning to send droids to Mars want to load the machines with lots of heavy equipment. The droids will also be built from stronger materials, all because of the relatively low gravity on the red planet. Everything on Mars is almost 3 times lighter than on Earth. Pluto's largest moon is half the size of the dwarf planet itself. This makes Charon, that's the moon's name, the largest known satellite relative to its parent size. There are 3 golf balls on the moon. They were launched during the Apollo 14 mission. Mathematicians claim white holes might exist, even though scientists haven't found one yet. If you came across a white hole, you wouldn't be able to enter it from the outside, but you'd see light and matter escaping from within. On our planet, one full rotation takes 1 day, but the sun is so enormous that it needs 25 to 35 Earth days to make one rotation. The moon is not a perfect sphere. It's shaped more like an egg because of the Earth's gravity. Spacesuits protect astronauts from huge temperature differences during spacewalks, from -250 degrees Fahrenheit to +250 degrees Fahrenheit. A neutron star gets born after a supernova collapses. After birth, it rotates extremely fast, about 60 times per second. But this rate can sometimes grow up to 600 times per second. In 2007, astronomers started to receive ultra-bright and ultra-strong radio signals. Named fast radio bursts, they were coming from somewhere billions of light years away. When astronauts are in space, they often see random flashes of light. They occur when cosmic rays hit the optic nerve in the eye. If you traveled around Pluto's equator, it would be the same distance as walking from Rome to New York City. If you visited GJ 504b, a planet located a mere 57 light-years away from Earth, you'd see that the planet is glowing. It's because of the heat left after its formation. The planet's color is a dull magenta, like a dark cherry blossom. Jupiter has the shortest day of all the planets in the solar system. It lasts just 9 hours and 55 minutes. Because of its fast rotation, Jupiter isn't a perfect sphere. It's a bit flattened. Venus has more volcanoes than any other planet in the solar system. There are at least 1,600 of them on the planet's surface, but most of them are extinct. Mercury has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. Nuclear pasta found inside neutron stars is believed to be the strongest substance in the universe. These noodles of neutrons can be 10 billion times stronger than steel. Some astronomers believe black holes might have no event horizon, aka the point of no return. Instead, there might be the apparent horizon. It can only trap stuff for some time. Later, matter or energy escapes, but in a different form. Each Apollo mission needed 15 spacesuits. Each member of the 3-person main crew needed 3 suits. One was for training, the second for flight. And there was also a backup suit, in case something went wrong with the flight suit. And each of the 3 members of the backup crew had 2 spacesuits, one for training and one for flight. Scientists believe Mercury might still have a partially molten core. It could explain why the planet has a magnetic field, even if it's just 1% as strong as Earth's. Dust storms on Mars are the most severe in the whole solar system. They can be raging for months on end. On planet Kepler 16b, which is 245 light-years away from Earth, not one, but 2 suns set over the horizon. The planet is as massive as our Saturn, but has a higher density. It takes 45 minutes to put on a spacesuit. After it's done, an astronaut needs another hour to adapt to new conditions. Earth-grazing fireballs are bright meteors that enter the Earth's atmosphere, but then leave it again. Triton, one of Neptune's moons, orbits the planet backward. It's the only big moon of any known planet to do so. Triton is also gradually getting closer to Neptune. Experts think that, eventually, the moon will be pulled apart by Neptune's gravity, and then it'll form a ring around the gas giant. Dwarf planet Haumea, which is further from Earth than Neptune, is truly bizarre. It's orbiting in the Kuiper Belt, a donut-shaped ring of ice objects circling the Sun. Haumea has 2 moons, a weirdly elongated shape, and a day that lasts 4 Earth hours. But the coolest thing, the dwarf planet is surrounded by incredibly thin rings. They're likely the result of an ancient collision. It takes Neptune almost 165 Earth years to make one full orbit around the Sun. In other words, since the gas giant was discovered in 1846, it's only circled the Sun once.
Humanity will once again visit the Moon. The mission is planned for 2024. In this crew, we'll see the first women step on the Moon. The main goal is to establish a lunar base for continued research that will help NASA prepare for an upcoming mission to Mars. Has been planning a crewed flight to the Red Planet set for the 2030s. Robotic rovers did a good job exploring the Martian surface, but astronauts will have to dig deeper to find evidence of water and any fossils proving microscopic life was once possible on our planetary neighbor. New data on Earth-like planets. Since its launch in 2009, the Kepler Space Telescope has discovered lots of exoplanets orbiting distant stars. Some of them have an Earth-like mass, composition, and orbits. NASA plans to launch a new generation of telescopes in the 2040s. They'll help us find real twins of our planet and even get pictures of their surfaces. The return of Halley's Comet. It'll be another 41 years before we once again see the most famous comet in the sky. Halley's visits us every 75 years, so some will manage to see it twice in their lifetime. The longest solar eclipse. 166 years from now, I'll still be around then, the sun will go dark for 7 minutes and 29 seconds. This is pretty close to the predicted maximum. It'll also be the longest eclipse human civilization has ever witnessed in its 10,000 years. Arrival of the most notorious asteroid. 1950 DA was once the most probable candidate among near-Earth objects we know to actually strike the planet. Fortunately, the chance was later estimated to be not even 0.1%. It'll most likely pass by on March 16, 2880. Mark your calendars. And it'll become solid evidence that we're safe for a while. The asteroid is more than a mile in diameter, enough to take out life on a planet. A new North Star? The Earth spins like a top. Watch one of these toys closely, and you'll see how its tip starts to draw circles in the air. The Earth's axis, an imaginary line going through the poles, goes full circle once every 26,000 years. It points at different stars along the way, thus changing the North Star. By the year 3000, the Gamma Cephei star will share this title with Polaris, as the Earth's axis will point right between them. The first near-Earth supernova. Antares is the 15th brightest star in the night skies. It's also an old red supergiant 12 times larger than the Sun. Stars this massive age to a point where they collapse in on themselves, producing huge supernovas. For Antares, this will happen just 10,000 years from now, which is nothing for a 12-million-year-old star. The resulting burst will be too far away to affect life on this planet negatively, but the light show will be visible here on Earth even during the day. Message to the universe. Delivered. Arecibo is the encoded message describing humanity, life on Earth, and the advancement of our scientific knowledge. It was broadcast from the Arecibo radio telescope and aimed at the center of the M13 cluster, 25,000 light-years away from us. In 25,000 years, it'll finally reach its destination. A new closest star. About 36,000 years from now, the Ross 248 star will become our new closest neighbor. It'll be just 3 light-years away from us and overtake the title from Proxima Centauri, which is a bit more than 4 light-years away. Ross 248 will remain the nearest star for around 9,000 years and then move away once again. So, you didn't like the neighborhood or what? The first interstellar human-made object. In 40,000 years, Voyager 1 will reach a point within 1.5 light-years of the Gliese 445 star. It successfully reached interstellar space in 2013. But, unfortunately, it won't be able to power up any of its systems somewhere beyond the year 2025. Voyager 1 has a message too, a recording of greetings in 55 languages, music from classical to rock and roll, and sounds of the Earth's wildlife. A bare Saturn. 100,000 years from now, Saturn will lose its beautiful rings. It'll happen gradually over time as the planet's colossal gravity pulls rocks and ice from this belt floating around it. They'll all eventually fall and get crushed and burned by Saturn's atmosphere. Well, how rude. The ring system is in the middle of its life cycle, so we're incredibly lucky we got to see it in its full glory. The most frightening supernova. The WR-104 star will burst into a supernova in 3,000 years. This star is 75,000 light-years away from us, and the blast won't touch us at all. But there is a small chance it'll also produce a gamma-ray burst in the process. If this stream of energy happens to aim right at us, it will negatively affect life on Earth. Good news? Scientists say that's very unlikely. Colliding moons. The moons of Uranus are part of a highly unstable system. Some of them have orbits that cross paths. Uranus already has 2 rings of debris from past collisions of its natural satellites. Desdemona and Cressida will crash into each other in the next million years and produce new rings. A star too close for comfort. The rogue Gliese 710 star is approaching our solar system, and it will get just 1 light-year away in 1.3 million years. This won't have a major impact on the planets, but it could disturb the so-called Oort cloud, which surrounds our solar system and is full of comets. From Earth, the star will look like the brightest planets we see now, and we'll see many more comets in the skies. The closest star to ever go supernova. Within a few million years, the Spica star, which is only 240 light-years from us, will burst into a supernova. Supernovae are a problem for life when they're 3 times closer than that, but the supernova itself will shine in the Earth's skies as bright as a full moon. A time capsule for future generations. The Lagios 1 satellite was launched back in 1976 to gather information about the exact shape of the Earth and tectonic plate movement. But it also contained information about civilization on Earth at the time. It'll re-enter our atmosphere in 8.4 million years. If humanity is around then, they'll learn how life on Earth was in our time. Well, at least how it was some 40 years ago. Rings for Mars. Mars' moon, Phobos, orbits really close to the surface, and it continues to get 2 feet closer every century. 50 million years from now, it'll collide with Mars, resulting in a massive amount of debris going into orbit and forming a ring system around the red planet. Oh, can't wait for that. Days on Earth will get longer. No, really? 1.4 billion years ago, the Moon was much closer to our planet. It made the Earth rotate faster, so the day was only 18 hours. The Moon is continuously moving away from Earth. In 180 million years, we'll gain 1 extra hour. In a little over 2 billion years, a day on Earth will be 36 hours long. No more solar eclipses. 600 million years into the future, the Moon will move away from the Earth too far to cover the Sun during eclipses. Those will become ancient relics. The Sun will get too bright. It'll take about 1 billion years for the Sun to raise its luminosity by 10%. This will be devastating for planets in the solar system, and life on Earth won't be possible beyond this point. By then, our species will likely have found a new planetary home. The Sun will swallow the inner planets. In 5 billion years, the Sun will begin to evolve into a red giant, growing hundreds of times its current size. It'll swell up so much, it will eventually engulf Mercury, Venus, and possibly Earth. The new Goldilocks habitable zone may shift to the orbits of Jupiter and Saturn. This process will take a bit under 3 billion years until the Sun reaches its maximum size. After that, our star will shrink into a white dwarf. The most epic event ever. Around the same time our Sun is swelled up, the nearest neighboring galaxy, Andromeda, will come too close to the Milky Way. If we could watch our galactic neighbor at this time, it'll get larger and larger as it approaches. Then the 2 galaxies will start to merge. Bright blue stars will burst into life. New constellations will form. The 2 spiral galaxies will now be a single giant elliptical one. Wow, I've set an alarm on my smartphone so I don't miss it.
When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the Moon. But it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite, an orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the Sun than our planet. So, when you're looking at the Sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the Sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called My-scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the Sun's rays, so only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets Mercury, Venus, Earth, and Mars don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, or they may be the remains of a moon that got destroyed by a collision with some space body, or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings. There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means that they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we know today as the Moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists call this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune and 10 times more massive than our home planet. It's likely to circle around the Sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the Moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the Sun as our planet and receives less sunlight and heat. But it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the Sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 miles per hour. Can they produce this heat? Or maybe it's because of the planet's core, or its gravitational force? There's a monster black hole hurtling through space at a speed of 5 million miles per hour. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us.
Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon, yet many moonquakes caused by our planet's gravitational pull sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets, which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1,200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying above. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees. and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite. According to their research, a small celestial body about 750 miles wide orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese.
There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has two moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of two parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The moon won't be able to block the sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system, but unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge. But it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, And when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the 5th largest out of the whole lot. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then.
Our sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere, there are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow has survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for 1 billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of 2 galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here.
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow, didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are two ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when two magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars and the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with two blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, They found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, my Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old. And from what we can see, one mysterious star, HD 1140283, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is, at least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space.
Deep in the heart of the Large Hadron Collider near Geneva, Switzerland, scientists have embarked on a journey to unlock the secrets of the universe. They've searched for the elusive Higgs boson, a particle that holds the key to understanding the universe itself. And after years of tireless experimentation, the impossible became possible. They finally discovered it. They uncovered a piece of the cosmic puzzle that had eluded us for decades. But what even is the Higgs boson? And why has that changed our understanding of the universe forever? And should you even care? Yes, you should. Just stick with me here. First of all, according to the standard model of physics, the universe is made up of tiny building blocks called particles. You know those, protons, neutrons, and muons. Wait, probably not that last one. Let's scratch it. Anyway, the Higgs boson is the fundamental particle associated with the Higgs field, a field that gives mass to other fundamental particles, such as electrons and quarks, which is not the sound that a duck makes, but close. First of all, let's describe the Higgs field. This is one of the fundamental fields of the universe, just like the electromagnetic field, for example, the one that gives us light and electricity. It's like a big, invisible ocean of energy that fills all of the space around us. And just like a real ocean, it has waves and currents. But instead of water, the Higgs field is made up of Higgs bosons. Now imagine you're a tiny little particle swimming through this ocean. Just like a boat in the water, you'll feel resistance as you move through the Higgs field. Some of these particles are like speedboats. They can zip through the Higgs field without feeling much resistance at all. And others, for example the W and Z bosons, are more like giant cruise ships. They're big and heavy, so they feel a lot of resistance as they move through the Higgs field. And that resistance is what gives particles mass. The speedboats that slide easily don't pick up any mass, but giant cruise ships interact with the field more strongly and pick up a lot of mass. Now let's describe that more, scientifically. When a particle interacts with the Higgs field, it creates a disturbance in the field, and this disturbance can be thought of as a Higgs boson. And the disturbance that it creates in the Higgs field is what gives mass to the interacting particle. Basically, without this field and the Higgs boson, tiny blocks of our universe, like protons and neutrons, wouldn't have the mass they need to make up atoms. Atoms wouldn't be able to form molecules. And without molecules, you wouldn't have anything. No matter, no stars, no planets, no life as we know it. Not even bright side. Ooh, makes me shudder. So not only is the Higgs boson incredibly important, but it's also mysterious and fascinating. That's where it got its beautiful, holy nickname from. The Higgs boson was first proposed in the 1960s by a physicist Peter Higgs. Good thing his last name wasn't Bozo. Imagine the Bozo boson. Anyway, Dr. Higgs was part of the group of brilliant scientists who were seeking to understand all the different types of particles that make it up. They noticed that some of them, like the photon, which carries light, don't have mass. But others, like the W and Z bosons, do. And they were like, wait a minute, how is this possible? That's when they generated two ideas, the Higgs boson and the Higgs field. But in order to confirm this theory, we needed some proof. And since we can't see the invisible field itself, we needed to find and track at least one Higgs boson. And finding it was an incredibly hard task, like a real-life game of Where's Waldo? All because the Higgs boson is very rare, very short-lived, and doesn't interact with other particles very often. Yep, it's just like me at parties. The Higgs boson is born when a particle passes through the Higgs field and decays almost immediately after that. Now, you may remember how much the science world rejoiced when they were finally able to discover it. That's because it took decades. First of all, this task was taken up by CERN, the European Organization for Nuclear Research. They were using the Large Hadron Collider, or the LHC for short. This is the largest and most powerful particle accelerator in the world, located near Geneva, Switzerland. It smashes protons together at incredibly high speeds, recreating conditions that existed just after the Big Bang. This giant machine tries to find new particles and helps us to understand the universe better. Anyway, the team at CERN used the LHC to generate trillions of proton collisions, searching for the telltale signs of the Higgs boson. But with so many collisions happening at once, it was like searching for a needle in the haystack the size of a small country. The search for the Higgs boson was a long and exciting journey that took decades of work and the collaboration of thousands of scientists from all over the world. And after years of searching, they finally found it, the evidence of the Higgs boson. The discovery was announced on July 4, 2012, and it was major news in the science world. It was celebrated by a lot of parties and events in CERN. But it wasn't over yet. The discovery of the Higgs boson had to be confirmed. So the scientists continued to study it and collect more data. And in 2013, they announced that the Higgs boson had been confirmed with a high level of certainty. This discovery was a really big deal because it confirmed a key part of the Standard Model of physics. The Standard Model of particle physics is the theory that explains how the universe works at its most basic level. It's a way for scientists to keep track of all the different types of particles and how they interact with each other. And the Higgs boson is like the VIP at this particle party. It's a crucial part of the Standard Model. Not only does it help to confirm the Standard Model, but it also highlights the need for new theories and models to explain what the Standard Model can't. Without the Higgs boson, the Standard Model wouldn't make sense, and scientists would have to come up with a whole new theory to explain why particles have mass. But with this holy particle, everything fell into place and the Standard Model was complete. It was like solving a giant puzzle or finding a glue that holds the universe together. Now, the discovery of the Higgs boson was a huge breakthrough for physics, but it also opened up new questions and possibilities for future research. So, what's next? Well, just like any good puzzle, there are always more pieces to find and more mysteries to uncover. Scientists in LHC continue their research and experiments with the Higgs boson. They're collecting data and analyzing it to better understand the properties of this particle. They're looking at how it interacts with other particles, how it decays, and even how it behaves in different conditions. Also, the Standard Model explains a lot of what we observe in the universe, but it still has some gaps. For example, right now, it can't explain things like dark matter and dark energy. So we've created another area of research, the potential new physics beyond the Standard Model of particle physics. This new area should include things like dark matter and gravity, and some scientists believe that the Higgs boson could become a crucial part of it. It could hold the key to understanding all these mysterious phenomena. To find out if that's really the case, scientists are currently searching for other particles that could be associated with the Higgs field, such as the Higgsino. They would be a new type of particle that could help explain, for example, how dark matter works. And lastly, researchers are also looking at the Higgs boson's role in the early universe. We want to see how it may have played a part in the formation of galaxies, stars, and even life as we know it. It's like a time machine that helps us understand how the universe came to be. So, all in all, the discovery of the Higgs boson opened a door to a whole new world of possibilities, and scientists are having a blast exploring all the new questions and mysteries that come with it. It's like a treasure map, pointing us to new mysteries to uncover and new theories to explore. Hey, perhaps there is a boson after all. You know, back in the 1970s, scientists discovered a mysterious gravitational anomaly called the Great Attractor. Wait a minute, I had that nickname in high school. Anyway, it's a place in the sky that draws hundreds of galaxies, including our Milky Way. You won't be able to see it because it's on the other side of the Milky Way, 150 million light-years away. The Great Attractor actually lies in the direction scientists usually call the zone of avoidance. I have one of those too. It's my closet. Now, there's so much dust and gas in this region that we can't see what's happening there. That area blocks most of the visible light from beyond. But all that dust and gas don't block X-rays and infrared light. So, as X-ray astronomy developed, researchers could finally start to observe all the objects within that area, including the mysterious force attracting everything. But so far, no one has figured out why it's happening. Our moon may be 200 million years younger than we previously thought. Many scientists believe that the moon formed during a powerful collision between our planet and an unknown Mars-sized body. The molten dust and debris got together and formed a new object we know as the moon. The lunar crust was probably going through a process of solidifying over a couple of 100 million years. Did you know about an early magma ocean on the moon? Scientists realized it was a real thing after they had discovered big amounts of the lightweight mineral called plagioclase. This material usually crystallizes and floats to the surface of magma. Anyway, this mineral was 4.36 billion years old, which means it formed 200 million years after the first solid materials had appeared in our solar system. Thus, the theory that the moon formed during this giant chaotic collision might be true. Now, if you stand on the moon one day and leave your footprint on its surface, it can stay there for 1 million years. You'd also see the footprints of other astronauts, even though no one has landed on the lunar surface for decades now. The moon doesn't have a full-fledged atmosphere. There's no breeze or anything else that can sweep up the dust and erase the footprints. We see it as a small dot somewhere in the distance, but in reality, the sun is so big that if it were an empty ball, you could fill it with more than 1 million Earths. The sun makes up 99.86% of the mass of our entire solar system. Another enormous object in our solar system is Jupiter. It's 11 times wider than our planet. For example, Earth isn't even the size of the Great Red Spot. This enormous storm has been raging on Jupiter for more than a century. And no, it's not anchored to anything solid, since Jupiter is a gas giant. It's like a massive hurricane, oval in shape, reddish in color, and wide enough to engulf our home planet. Once upon a time, it was 3 times as wide as our planet, but over the last few centuries, it's been shrinking as well as growing taller. As for Jupiter, this gas giant is some sort of vacuum cleaner that keeps our solar system safe. Jupiter has incredibly strong gravity that eats up comets or asteroids that might potentially harm our home planet. In some other planetary systems, gas giants similar to Jupiter migrate from the position where they formed. They spiral inward and come closer to their parent stars, and as they travel, they swallow up small rocky planets. Or their strong gravitational force flings these planets out of their star systems. Luckily for us, Jupiter's gravitational force doesn't work that way. If Jupiter-like planets stay away from their stars, they keep their planetary system safe, protecting those small planets in their inner orbit. Jupiter, for instance, can change the orbits of small space bodies that come too close to the inner planets of our solar system. That's why this gas giant is a good guardian of our solar system. Now, there's a supermassive black hole that roams through space at a speed of 3 million miles per hour and leaves a trail of debris behind. Hey, I had a little brother who once did that. It's about 1 million times as heavy as our Sun and, at the moment, 2 billion light-years away from Earth. This black hole started like any other, in its own elliptical galaxy with many stars surrounding it. Supermassive black holes often form and remain in the center of galaxies. But this one got away. One theory claims that this black hole is different because the galaxy where it formed may have bumped into another galaxy at one point in the past. Sometimes galaxies merge into a new one if this happens, but not this time. Instead of merging, the black hole's galaxy passed through a way bigger one millions of years ago. That giant galaxy already swallowed up some other galaxies along the way. And since it was so large, the galaxy surrounding our supermassive black hole ended up ripped apart. The black hole at its center managed to run away with some of the nearby stars. That's what left a burning trail stretching across the surrounding space. Solar superstorms are so powerful that they can cause blackouts all over the world. Random flares coming from the sun cause solar storms, and they can really happen at any time. Back in 2012, we were lucky because the strongest solar storm in over 150 years passed very close to us. It just tore through Earth's orbit. If it had happened only a week earlier, our planet would have had to deal with tons of terrible consequences, including power outages all over the globe. Gamma-ray bursts are strong enough to destroy planets. We're talking about extremely strong bursts that mostly occur in galaxies very, very far away. If these rays are pointed directly at some space object, they can completely wreck it, even if we're talking about an entire planet. So Earth is safe for now, and we have nothing to be afraid of. A gamma-ray burst happens in our galaxy approximately once every 5 million years. Luckily, it occurs too far away and doesn't affect life on Earth. That's what I call irrelevant, but still scary. A burning ice is a thing. It may be hard to picture it here on Earth, but one strange planet called Gliese 436b is literally a burning ball of ice. It's covered with ice, but at the same time, it has temperatures of 822 degrees Fahrenheit. You can't actually see the planet burn since there's too much water on the planet. It's because of the strong gravitational force that pulls the water molecules to the core of the planet and packs them together incredibly densely. That way, water molecules can't evaporate, which is why the ice on the planet's surface doesn't melt. There are stars that can munch on other stars. These space objects are mostly smaller stars with a lower mass. They target the closest stars and begin to absorb their hydrogen fuel to boost their own mass and generally live longer. A vampire star becomes strikingly blue. It also gets hotter. This way, it seems that it's way younger than it actually is. If a star, or basically any other object, falls into a black hole, it gets stretched like spaghetti. This process is even called spaghettification. The gravitational force of a black hole stretches an object in one direction, but at the same time squeezes it in another. And telescopes have captured such a process a mere 215 million light-years away from us. An unlucky star was wandering too close to a supermassive black hole at the center of a galaxy. The The star, which was approximately the same mass as our Sun, didn't stand a chance against the extremely strong gravitational pull of the black hole. After all, the black hole we're talking about was over 1 million times as massive as our star. Astronomers were lucky to record this event, because after a black hole eats a star, it often spits out its material in the form of dust, so it's hard to see what's going on there. Anyways, this picture of the black hole, was it a spitting image? Hey, what did you expect to rate? Okay, I'll stop now. So, you're driving down the highway, and an 18-wheel tractor-trailer is coming up fast behind. You've got to change lanes. You look in the mirror. Is there enough space? And you notice the words on the mirror. Objects in the mirror are closer than they appear. No kidding! Well, it's the same with the Milky Way galaxy. There's another galaxy headed this way, and like the tractor-trailer, it's closer than it looks. The Andromeda Galaxy, or M31, as it was labeled originally by Charles Messier in his catalog of 110 fuzzy objects in 1774, is now officially named NGC 122, that's New Galactic Catalog 122. A spiral galaxy larger than the Milky Way, the Andromeda Galaxy is so big and so close that you can see it without a telescope. In fact, it appears with the unaided eye half as wide as the Moon. It's estimated that the Andromeda Galaxy contains 1 trillion stars, compared with the Milky Way's estimated 300 to 400 billion measly stars. To see the Andromeda Galaxy, you must allow your eyes to become dark adapted. This might take about 10 minutes while your pupils dilate to take in as much light as possible. M31 is best seen from late summer through winter, when the great square of Pegasus the Winged Horse is overhead. Draw a line across the great square diagonally upwards from the lower corner star, then go a little further beyond the square. There it is! But you still won't be able to see how big it is unless you peek at it from the corners of your eyes. If you stare straight at it, the galaxy will tend to fade away. You must use your peripheral vision to see how big the Andromeda Galaxy appears. Peripheral vision, or averted vision, allows you to see light more sensitively at night, but without color. Sailors have used averted vision for centuries to see faint lights out on the ocean or on land. Aristotle used averted vision to observe star cluster M41 in Canis Major, as he described in his book Meteorologica. In a telescopic photograph, the Andromeda Galaxy appears 6 times wider than the Moon, because with the unaided eye, we can only see the bright center of the galaxy. A telescopic photograph shows how massive M31's spiral arms really are. And this beast of a galaxy is headed our way. We are looking at a future massive collision of galaxies of, well, galactic proportions. When that happens, humanity may need to relocate to another galaxy to inhabit. Perhaps we'll go to the Pinwheel Galaxy in the asterism of the Big Dipper. How do we know the Andromeda Galaxy is moving towards us? With a tool called a spectroscope. After the camera, the spectroscope is the most important attachment to a telescope. Oh, except for the human eye. Our eyes only see light. You don't have this big horse in your eye. You only have the light being reflected by the horse in your eyes. The same with space. We only see the light coming from there. So, if we are going to understand space, we need to understand light. And that was not an easy task for astronomers of the 19th century. The invention of the spectroscope was a big breakthrough in understanding light coming to Earth from space. With a spectroscope, astronomers can tell which direction objects in space are moving, as well as which elements are making the light. When you hear an ambulance approaching, you hear the siren getting louder and higher, and when it passes you and goes away, you hear the siren sound get weaker and lower. The change in pitch frequency depends entirely on the motion of the source. This is called the Doppler effect, after the Austrian physicist and mathematician Christian Johann Doppler, who first explained the effect in 1842. The ambulance siren is not changing its volume. The sound waves are being compressed as it is approaching and stretched as the ambulance recedes. The spectroscope shows that light waves show the same Doppler effect as sound waves. They are compressed as the star or galaxy is approaching us and appear stretched when it is receding. Therefore, the light from an approaching galaxy will appear slightly bluer, the blue shift. a slight increase in frequency, and the light from a receding galaxy will appear slightly redder than normal, or redshift, a slight decrease in the light's frequency. In 1929, Edwin Hubble, after whom the Hubble spacecraft is named, published his spectroscopic study of 46 galaxies, the light from all but one of which was redshifted, moving away. Hubble's study provided the first evidence that the universe was expanding. The farther away a galaxy was from the Milky Way, the faster it was moving away. This was also the first evidence that the universe began with a Big Bang. The one galaxy whose light was blue-shifted, moving towards the Milky Way, was M31, the Andromeda Galaxy, the closest galaxy. 250,000 miles per hour seems a pretty high speed at which to have a collision. That's the speed spectroscopic measurements of the blue shift of Andromeda indicate. It's going to be a big mess when it happens. But when is it going to happen? To determine when the two galaxies will collide, we need to determine the distance between them, and for that we need, boom, supernovas. Type 1a supernovas are what are called standard candles. Just as we know how bright a candle shines, we know how bright a Type 1a supernova shines, its absolute magnitude. A Type 1a supernova appears when a white dwarf collapses under the pressure of all the gas it has been gravitationally slurping from a companion star. Looking at the Andromeda Galaxy and measuring the apparent brightness of a supernova in the galaxy, it is possible to calculate its distance away from us. Because the intensity of light dims inversely with the square of its distance away, which is called the inverse square law, by comparing the apparent brightness of a supernova in the Andromeda Galaxy with its absolute brightness, well, we get an approximate distance of 2.5 million light-years. Since 1 light-year is approximately 6 trillion miles, and the Andromeda Galaxy is 2.5 million light-years away, even though it is approaching at the speed of about 250,000 miles, we have about 4 billion years before the big collision. So you can wait until after lunch, maybe dinner, to start packing. As an aside, if we see the Andromeda Galaxy as it was 2.5 million years ago, and it has been moving toward the Milky Way all this time, how big in the sky would it appear now? Quite as big as that tractor trailer in your rearview mirror. But do we really have 4 billion years before the galaxies crash? There are several other factors to consider. The minor galaxies that are gravitationally linked to both the Milky Way and the Andromeda Galaxy will be swallowed up by their host galaxies. Considering the lopsided mass distribution that will result, the galactic collision of the Milky Way and Andromeda will be affected. Some scientists are saying it won't be a direct hit, but more of a sideswipe. And then there's the galactic halos of each galaxy. Here's what Project Amiga has found out about the halo of stars and gas surrounding the Andromeda Galaxy. Using the Hubble Space Telescope, researchers were able to observe how the light from bright distant quasars were being absorbed by the mostly invisible gas around the Andromeda Galaxy. Look at the results. Notice M31 in the center. If the same is true of the Milky Way, and there's no reason to think it would be different, then the halos of the two galaxies are touching now. The collision has already begun. There is also a question about what effect the dark matter clouds around each galaxy might have on an impending collision, or are having now. But enough of speculation. In 4 billion years, the Sun will have increased brightness on its way to becoming a red giant star. And humans will have already found another galaxy to inhabit. Happy traveling, dear humans!